Assalamualaikum and hi to everyone. Welcome back to my channel. So in this video, we'll continue on the multiplexing. So we'll discuss about the example of multiplexing using FDM. Okay, look at this example. Assume that a voice channel occupy a bandwidth of 4 kHz. Okay, we need to combine 3 voice channels into a link with a bandwidth of 12 kHz. So we have 3 channels and the bandwidth total is 12 kHz. Okay. The span of the bandwidth starting from 20 kHz until 32 kHz. So total we have 12 kHz. Show the configuration using the frequency domain and assume there are no guard band. So in this situation, we can assume there is no unused bandwidth that available. Only the bandwidth that we have only allocated for the process of FDM. So we shift each of 3 voice channels to a different bandwidth. So we have 3 channels. So the first channel is start from 20 to 24. Okay, because we have 3 channels and the total into 12 kHz. So 12 divided by 3 equal to 4. So each channel we need to allocate 4 kHz. And the bandwidth starting from 20 to 32. Okay, so the first voice channel, we allocate 20 to 24 kHz. The second one, we put 24 to 28. And the third part, we put 28 to the 32. So based on this option, we can configure this diagram. We have 3 voice channels. So total bandwidth that need to be used is 12 kHz. We have 3, so 12 divided by 3. So each signal we have 4 kHz. So the first voice we put under 20 until 24 bandwidth. The next one 24 until 28. The third one 28 until 32. So the span of the bandwidth starting at 20 and end at the 32. And then we combine all the signal using the multiplexer. Okay, this one we combine, so 20, 32. And transmit this using a single link, which is the higher bandwidth that we have, and go to the receiver side. So at the receiver side, it will go through the demultiplexer, and then it will be separated again into a single voice channel. In next example, we have 5 channels. Each of the channel with 100 kHz bandwidth. So those channels need to be multiplexed together. What is the minimum bandwidth of the link if there is a need for a guard band of 10 kHz between the channel in order to prevent the interference, to prevent the overlapping between channel to another channel. Okay. Channel that we have is 5, each with 100. The question asks how many bandwidth. So for 5 channel, we need at least 4 guard band. How to calculate the guard band? How to know? We have 5 channels, so 5 minus 1. N minus 1 refer to total of guard band that we need. So 1 guard band equal to 10 kHz. One channel has 100 kHz. So 5 times 100 plus 4 times 10. Okay, this part for the guide band, this one for the transmission. So total you need is 540 kilohertz of the bandwidth in order to transmit signal from 5 channels with 100 kilohertz bandwidth to the receiver side. Okay, this is the illustration. The total bandwidth that you need is 540. Is on this one 540. So you have 5 channel. So between each channel, you must put the guide band. So 100 plus 10 plus 100 plus 10 plus 100 plus 10 plus 100 plus 10 plus 100. Total you have is 540 kilohertz. So this is total bandwidth that you need in order to allow you to use the multiplexing. Okay, application of the FDM. Okay, we can refer to the television broadcasting, radio broadcasting. So those television and radio use the analog signal before this. Okay, currently we already have the digital signal. So before we have the digital signal, we use the analog signal. So we apply the process of FDM technique into the television broadcasting as well as for our radio broadcasting. Okay, the next point, we will talk about the WDM. So WDM is about the wavelength division multiplexing. Okay. This technique is implemented over the fiber optical signal. So WDM is an analog multiplexing technique to combine the optical signal. It is analog multiplexing, but the signal that it combined is referred to the optical signal. So this WDM is used at the SONET network. Okay, at the signal network, which multiple optical signal or multiple optical fiber lines are multiplexed and demultiplexed using the WDM. So the difference between the FDM and WDM, in FDM we combine the bandwidth together. We combine the signal. In WDM, we combine the wavelength of the optical signal. And then we have the multiplexer and demultiplexer. In the WDM, the multiplexer and multiplexer is using the prism. Okay? So we have optical signal, and each optical signal have their own wavelength. So we combine that wavelength together and then transmit using a single link and separate it again those optical signal. Okay, and then it's look like this one, the multiplexer and the multiplexer using the prism. So that's all for example of the FDM and a little bit overview on the WDM. So the next video will discuss on the TDM. So thank you and Assalamualaikum.